Okay, so these are notes on complex numbers, which are just the imaginary numbers. So an imaginary number is I, which you should be familiar with, is just I is equal to the square root of -1. But if you didn't know that, now you know. So I is just equal to the square root of -1. So before, when we would get to the square root of a negative number, we'd stop. Well, now we can actually find out what that number is because it's imaginary. So what we're going to do is we're just going to simplify some things. So if I have the square root of -9, then that tells me right away that it's going to be an imaginary number because it's a negative number and you can't take the square root of negative. So how we do this is we break it up. So square root of -9 is really just going to be the square root of 9 times the square root of -1. They are the same thing. All I did was break it up. Because remember, 9 times -1 is -9. Well, square root of 9 times square root of -1 is also square root of -9. And then the reason why I did this is because now I can break it up. Because I know what the square root of 9 is. The square root of 9 is 3. Oops. There. It's 3. And then the square root of -1 is I. So it's 3i. So that's the answer. The square root of -9 is just 3i. Zoom in so we can actually see it. So now I have the square root of 3 times the square root of -12. Now looking at this, I can't actually, the square root of -12 reduces, but the square root of 3 by itself isn't actually anything. So what I'm going to do is actually multiply these together. And when I multiply them together, 3 times -12 is -36. So I get the square root of -36. And then when I break that up, I can, again, 36 is a perfect square, which just means I can actually take the square root of it. So I'm going to break it up into the square root of 36 times the square root of -1. And when I do that, it's going to reduce to 6i, because square root of 36 is 6, and square root of -1 is I. So 6i is the final answer. So pretty easy. Now that we've talked about reducing imaginary numbers, we're going to talk about what a complex number is. So a complex number is a number z such that a plus bi. So it's just of the format a plus bi, where a and b are both real numbers and I is an imaginary number. So z, so basically what that is saying is that this whole thing is equal to z. That whole thing is an imaginary number. Not imaginary, but a complex number. So that is actually z. And again, you want to remember that a is real and b is real. So we're just going to make a note that those are actually the real numbers. And then I, which hopefully you've noticed now, I just made this imaginary. So the first part is all real, and then the second part is imaginary. So it's just it's a real number plus an imaginary number. And that is the form of a complex number. So even though there's two pieces, actually the whole thing together is one number. Okay, so we're going to add complex numbers. And how we add them is they're just like combining like terms. It's the same thing that we've been doing for days. So you have 3 minus 4i plus 2 plus 5i. So this is actually one complex number, and this is one complex number. And what I'm going to do right now is add them together. And I do that by combining like terms. So what I'm going to do is I'm actually just going to reorder it by having all my real numbers together and then adding my imaginary numbers last. So I have 3, and then if I move this 2 over here, I have plus 2. And then that takes care of all my real numbers, minus 4i, and plus 5i. So all I did was reorder it so my real numbers were together and my imaginary numbers were together. And now I simplify by combining the like terms. Well, 3 plus 2 is 5. And -4 plus 5 is 1i, or just I. So my answer is 5 plus I. So hopefully you're not having too much of a hard time with it. It's not the worst thing in the world. All right, so we've learned how to add. Subtracting is the same thing, but of course, multiplying is a little bit different. In multiplying, we're going to use the distributive property and we're going to FOIL. So if you remember that, on my middle school math classes, I called it the math rainbow. So I'm multiplying the 3 to everything and then the -4 to everything. So let's do that. Let's make some math rainbows. So I'm going to multiply 3 to 2 and 3 to 5. And I'm just going to do this part in its own color. So then I get 3 times 2 is 6. And 3 times 5i is 15i. Okay. So that takes care of that. And then now I have to multiply or FOIL the next term, which is the -4 to 2 and the -4 to 5. And when I do that, I have -8i, and then -4i times 5i is -20i squared. So this is actually all still part of the same math sentence. So what I'm going to do now is combine my like terms. So I'm going to have, we'll go back to using the equation tool. 6 is the only real number, so it's 6. And then I got this 15i minus 8i. Well, 15i minus 8i is 7i. And then I still have minus 20i squared. Now we're going to pause for a second because I squared is a new term. We don't know what I squared is. Well, remember how I is equal to the square root of -1, right? Square root of -1. Then I squared is equal to the square root of -1. Well, actually, what's equal to is I times I, which is equal to the square root of -1 times the square root of -1, which is just equal to -1. The square undoes itself. So that is just one really long explanation to let you know that I squared is equal to -1. They are the same thing. So basically what that means here is, see how I have this I squared here? I can just replace it with -1. So that's what I'm going to do. I'm going to rewrite this as, what do we have? 6 plus 7i minus 20 times -1, which is just 6 plus 7i plus 20. And I'm going to combine my like terms. So 20 plus 6 is 26. So my answer is 26 plus 7i. And so that is how you multiply complex numbers. So next thing we need to talk about is a conjugate. And so a conjugate is just an opposite complex number. So in this case where I had 26 plus 7i, the conjugate is actually, I wonder if there's an arrow. Yeah. The conjugate is just the opposite. So it's 26 minus 7i. So basically just the sign of the middle term cancels. So that is the conjugate. It goes from this to this. Likewise, it can go backwards. If I had 26 minus 7i, then the conjugate would be 26 plus 7i. Okay, last thing we're going to do today is learn how to divide complex numbers. And so how you do that is you multiply the denominator by the conjugate and simplify. So if my denominator in this case is 4 minus I, then the conjugate of 4 minus I is 4 plus I. So I'm going to multiply the top and the bottom of the fraction by 4 plus I. So I have 4 plus I on the top. And then I'm going to have 4 plus I in the denominator. Then I'm just multiplying it by the conjugate. And actually, we're going to put some parentheses around it so that way your instincts of foiling will kick in. Okay. Thank you. All right, so now that I got it, now I'm going to do some FOILing. So I'm going to multiply everything on top and everything on the bottom. And when I do that, in the numerator, or the top of the fraction, I'm going to get 2 times 4 is 8, plus 2 times I is 2I, and 5i times 4 is 20i, so plus 20i, and then 5i times I is 5i squared. So that's what happens when I multiply 4i to the numerator. Now if I multiply 4i to the denominator, I'm going to get 16 plus 4i minus 4i minus I squared. Okay, so this is what I got. So what I'm going to do is just combine my like terms and replace I squareds with negative ones. So I'm going to have 8 plus 22i, because 20 plus 2 is 22, plus 5 times negative 1. And in the denominator, I'll have 16. My i's cancel, minus negative 1. Okay, but I'm not done yet. I need to keep doing some math. So now, did I just change it to the same color? I think I did. I don't know what I did. Anyways, 8. I'm really going to have 8 minus 5. And then plus 22i over 16 plus 1. And we're almost done. We're not quite there, but we're getting really close. If I combine my like terms, I'm going to have 8 minus 5 is 3 plus 22i over 17. Now, you would think you could stop here, but remember, a complex number has a real part and an imaginary part. So what we're going to actually do is just break this up into 2 parts, because remember, this is 3 divided by 17 plus 22i divided by 17. So my final answer is just going to have it split up. So I'm going to have 3 over 17 plus 22i over 17. And that is actually my answer. Mom, I got you a pizza. Thank